Hello kids, I'm Chavi Bansal and today we are going to start a very interesting chapter called Liquid Solutions. You might have heard the chapter. This chapter belongs to the physical chemistry. If you have seen the NEET 2025 paper or JEE Mains and JEE Advanced paper, you'll be aware that the physical chemistry has taken toll over the inorganic and organic chemistry, right? And out of physical chemistry also, solutions chapter has been a very important chapter. In NEET 2025 paper, there were 4 questions, literally 4 questions out of 45 were from solutions chapter, which makes this chapter very important. And not even just the importance, it is very easy and very convenient chapter. A few topics of this chapter are basically related to the mole concept also. So it forms the basics of the 12th grade chemistry. Okay, let's start with this. Before I start, I would like to tell you it's not only for the NEET students, even the JEE students can see the video, understand the concepts, and there are a few questions that we are going to discuss of JEE Mains and JEE Advanced level. Okay, let me share my screen. Okay, I hope you guys are able to see my screen. One second. Yeah. Okay. So the chapter name is Liquid Solutions, right? What comes to our mind when we think about the name solutions? It's generally the water which has a spoon of sugar or a spoon of salt, right? This is something that we all can relate to. And that is the first thing that comes to our mind when we talk about solutions. But is that the only thing? No. So what is solutions? Solutions are actually a homogeneous mixture of two or more than two non-reacting components. Okay. What is solution? It is a homogeneous mixture of two or more than two non-reacting components. Now let's understand one and small terms that are given in this definition. So non-reactant components means there is no chemical reaction taking place. They are just physically mixed to form a mixture. Okay. So this non-reactant means chemically no reaction is taking place. Okay. Now homogeneous mixture. How you will define a homogeneous mixture? See, a mixture can be of two types, a homogeneous and a heterogeneous. In homogeneous mixture, the solute or the particles are uniformly distributed, correct? Or other way to understand is you cannot see the physical boundaries between the components. They are uniformly mixed with each other. So solution is also a type of a homogeneous mixture. Now tell me, like I already took an example of water and a tablespoon of sugar or salt being added to it, right? But is it always two components? Can it be more than that? Yes, lemonade is one of the example, right? We add salt also, we add sugar also, we add some amount of lemon syrup also, we add some water as well, right? So solution is, it is not necessarily made up of two components. Okay, it can be made up of, when it is made up of two components, it is called as binary solution. Okay, when it is made up of three components, it is called as tertiary, and so on. So it is not necessary that a solution has only two components, it can be more than two also. But in general, we talked about binary solution, and this chapter also we are going to mostly deal with the binary solutions only. So what is binary solution? As I told you already, it is a solution of two components. One is solute and the other is solvent. We have very basic idea of what is solute, what is solvent. Like if I take an example of a sugar being added into a glass of water, it will be called, sugar will be called as solute and water will be called as solvent, right? So the very basic definition or the very basic idea about the solute and solute is something which is added to solvent, right? It is also generally present in a lesser quantity, correct? Whereas solvent is something to which solute is added, right? And it is generally present in higher quantity, more quantity, correct? This is what we know about solute and solvent, right? But for example, if I take 1 glass of water, means nearly 200 grams of water I have taken, and if I add 300 grams of sugar to it to make a sugar syrup, then which one is solute and which one is solvent? Will the solute be sugar or water? See, according to the definition that we have done so far, it should be water that is solute and the solvent should be sugar because the amount of water is lesser than the amount of sugar, correct? But that's wrong. There is a very important point which we have missed to define which is solute and which is solvent. Always remember the physical state of a solution is always a physical state of its solvent. What does this mean? For example, even if I'm taking 200 grams of water and adding 250 grams or even 210 grams of sugar to it, the syrup that is being formed, it is still liquid, right? It is still a fluid. So the state of the solution is liquid and the state of the solvent is also going to be liquid. And when we are mixing water and sugar, it's water which is in the liquid state. So the water will be the solvent and sugar will be the solute. Clear? So these are the very basic definitions and very basic terminologies which is related to the solutions chapter. Okay. Now, there is some part which is related to the solutions chapter and also part of mole concept. Okay, but before that, acha, abhi tak we have taken an example that comes to our mind whenever we think about solution, right? It's a solid solute and there is a liquid solvent. But is it always that the case that it's always a solid solute or maybe a liquid solute added to a liquid solvent? No. A solute can be of any physical state. A solute can be a liquid, a solid, or a gas. Same way, a solvent can be anything, a solid, a liquid, or a gas. So it makes out 9 different combinations of solid, solutes, and solvents. And there are a lot and lot of examples which are associated to it. So if you are watching the video, I would like you guys to give this homework. Find out the examples of solute and solvent present in different states. Means if solute made this table, if there is a solute, then solvent, physical state you have to mention and then their example has to be written. Okay? So if solute is solid, solid and solid, then liquid, liquid and liquid, then comes gas, gas and gas. Same way, it has to be solid, liquid, gas, solid, liquid, gas, solid, liquid, and gas. So these are the 9 different combinations that you can see on the screen. You have to find out the examples of the solutions that belong to these categories. Okay, and keep me posted in the comment section so that I can check if whatever you have given the example are the correct example of this given combination. For example, air. Air is a mixture, right? Air is also a solution, which is mixture of what? Gases. So gas into gas. Gases are there. There is a gas which is in major quantity like nitrogen, and there are gases which are in a very smaller quantity like CO2. So it makes it a gas into gas solution. Okay, clear? Now, next part is concentration terms. This part is mostly related to what we have done in the mole concept, but this forms the very important part of solution. So we are going to have a very brief revision about it, and then we'll do a lot of questions on the concentration terms. Clear? So the first concentration term that come to my mind is percentage. Percentage means what? Percentage means if this percentage can be defined into three different terms. Percentage by weight. Okay. Second can be percentage of weight with volume. And then percentage by volume. Now, what does this mean? So percentage by weight. It means W by W. What does W by W mean? How much grams of solute is present in 100 grams of solution? Okay. What does this percentage by weight means? How much grams of solute are present in 100 grams of solution. Okay. For example, someone says there is 80% W by W glucose solution. What does this mean? It means 80 grams of glucose is present in 100 grams of solution. We are not talking about solvent. Always remember, it's always about solution. In most of the concentration terms, it's always about solution. So it means 80 grams of glucose is present in 100 gram of solution. Okay. This is what percentage by weight means. Next is percentage of weight by volume. This is written as W by V. Okay. This means how much grams of solute are present in 100 ml of solution. Okay. Same 80% glucose solution we have taken before. We'll take the same example. If it is 80% W by V, what does this mean? It means that 80 grams of glucose is present in 100 ml of solution. Okay. So this is the difference between W by W and W by V. The last that we have is percentage by volume, which means V by V. Again, if I'm taking, okay, let's not take the glucose solution. Let's talk about, for example, 50% H2SO4 solution. Okay. This is given V by V. Okay. What does this mean? This means 50 ml of H2SO4 is present in 100 ml of solution. Okay, this is what it means. So these are the three percentages that we discuss: percentage by weight, percentage of weight with respect to volume, and percentage by volume. Clear? After this, the very important concentration term is molarity. What is molarity? Molarity is represented with capital M, and it is equal to number of moles of solute divided by volume of solution in liters. Okay, volume of solution in liters. This is called as molarity. Now, if the volume of solution is not given in liters, you can convert it into ml, and the formula will become number of moles of solute divided by volume of solution in ml multiplied 1000. This will become the formula of molarity. Okay. This is very, very, very important formula because molarity is something that we are going to use for so many chapters coming ahead in chemistry. So do not forget this formula, molarity. Okay. Next is molality. It is represented by small m, molality. What does molality means? Molality means number of moles of solute with grams of solvent in kg is called as molality. Remember, this is the only concentration terms that uses the amount of solvent in the denominator instead of solution. That too in grams. Okay, so this is also a bit different from molarity, and this is also one of the important concentration term. So we can also write it as number of moles of solute divided by grams of solvent into 1000. Okay, or amount of solvent instead of here grams because it becomes tricky. Amount of solvent in grams. Here we can use grams of solvent. Okay, this is the second very most important concentration term. Clear? Next comes normality. Normality is represented with capital M. Normality is a bit different from molarity and molality because it does not use the number of moles of solute directly. Okay, so what is the formula of normality? Number of gram equivalent of solute divided by volume of solution in liters. Okay, what is normality? Normality is number of gram equivalent of solute present in 1 liter of solution. Now, it is confusing. What is gram equivalent, right? So, this is very important because going ahead in the chapter, the gram equivalence will be required. It will be required for many chapters. So, do not forget what is the formula of gram equivalence. So, gram equivalent, as the name suggests, grams and then equivalent, right? So can I write gram equivalent as grams of solute divided by equivalent mass of solute, right? As the name suggests, grams of solute and equivalent mass of solute, correct? Second. So, but again, what is this equivalent mass? This equivalent mass is nothing but molar mass divided by n factor. You have heard this n factor before also. We have done the n factor in redox reaction. We have done the n factor in the mole concept. So this is nothing but molar mass divided by n factor. For people who are seeing it for the first time, n factor for an acid is number of hydrogen ions it can release. Okay. For base, it will be number of OH ions it can release. For a metal, will be its valency or charge. And for any component or compound which is undergoing the redox reaction, it is the number of moles of electron being transferred per molecule of the substance will be the n factor. Okay, so this n factor, its definition keeps on changing on the basis what we are using in our reaction. Clear? Now, this is what normality is. Now, this normality, molarity, molality. Okay, there is another term called as formality. It sounds weird, right? But formality is nothing. It is molarity of ions. Okay. For molar mass, instead of using molar mass, we'll be using formula mass, which is the mass of ions. That is called as formality. Okay. Next, we can talk about mole fraction. This is also very important, going to be very important part in solutions chapter itself. What is mole fraction? So now, for example, there are 3 to 4 components present in a mixture. Okay. So for example, let's take there are 3 components present, A, B, and C. So what is the mole fraction of A? The mole fraction of A will be equal to number of moles of A divided by total moles, total number of moles. Or I can write number of moles of A divided by moles of A plus moles of B plus moles of C. Okay, which gives me the total number of moles. So can I write mole fraction is equal to number of moles of one component divided by total number of moles. Okay. So for example, let's one second, let me put it in a box. Now, for example, you are given with the gaseous mixture and there is 10 moles of N2, 15 moles of O2 and 20 moles of CO2. Okay. Now, these three gases are present and you have to find out the mole fraction of O2. O2 mole fraction. Okay. So, how you will find out? So, number of moles of O2 gas divided by total number of moles, which is equal to 15 divided by 10 plus 15 plus 20. 15 divided by 45, which is 1 by 3. So this is the mole fraction of O2 present in the mixture. Clear? This is how you define the mole fraction. Okay, after mole fraction, we can talk about volume strength. Before that, let's talk about ppm. ppm means parts per million. What does this mean? It means if there are million particles or million, one second, if there are million particles of solution, how many parts of it is of solute? Okay, so this terminology is used for something which is very, very minute quantity of solute is present or very high diluted solutions are there. No, for that we will use ppm because the concentration of solute particle is very less. This can be also divided into three, different with respect to three, that is W by W, W by V, and V by V. So it can be grams of solute divided by grams of solution into 10 raised to power 6. Okay. Or it can be grams of solute divided by volume of solution into 10 raised to power 6. Or grams, sorry, volume of solute divided by volume of solution into 10 raised to power 6. This is called as parts per million. Okay. Then we have second. Next, we have strength of solution. One second. So next we have strength of solution. This strength of solution is nothing but is equal to grams of solute divided by volume of solution in liters. Okay, so it is not molarity, it is not density, but in between, which is equal to grams of solute divided by volume of solution in liters. Clear? So what we have done so far, we have done percentage by weight, we have done percentage of weight by volume, we have done percentage by volume. We have also done molarity, molality, and normality. We have done formality, mole fraction, and then ppm and strength of solution. So these are the various concentration terms that can be used in finding out the different concentrations of a solution. Okay. We might also need to understand the interrelationship between these concentration terms, which are generally asked in the question paper. So the first one is relation between normality and molarity. Okay. So what is the relationship between normality and molarity? Let's see. See, normality, what is the formula of normality? Number of gram equivalents divided by volume of solution into 1000 if volume is in ml, right? And what is the formula of molarity? Molarity is equal to number of moles divided by volume of solution into 1000, right? So it is almost similar. It's just that the gram equivalence, we can write normality equals to grams divided by equivalent mass divided by volume of solution into 1000. Okay. Right? Equivalent mass. Now we can write normality also equal to grams of solute. What is equivalent mass? It is molar mass divided by n factor, right? Overall volume of solution in ml multiply with 1000. Now, if you clearly see, if you have observed this gram, this volume, everything other than this n factor does not give you the idea of number of moles divided by volume into 1000, which is molarity, right? So if you observe it clearly, normality is nothing but the molarity into n factor. This is a very important relationship where normality is equal to nothing but molarity into n factor. Okay. And generally normality is greater than molarity because n factor is either 1 or it is greater than 1. Okay. So this is one of the important relationship between normality and molarity. Clear? We can also find one more relationship, which is, one second. Which is relationship between molarity, percentage W by W, and density. Okay. How? See, what is density? Density is mass upon volume. Correct? Now, if we are talking about density of solution, it will be mass of solution upon volume of solution. Enough? Correct? Now, let's write down the formula of molarity. Molarity is number of moles of solute divided by volume of solution in ml into 1000. This is also in ml. Now, molarity can also be written as, okay, instead of molarity, can we find out the value of this volume of solution in ml? It will be equal to number of moles of solute divided by mass of solution by density of solution into 1000. Correct? So can I write number of moles of solute into T into 1000 divided by mass of solution? Correct? Now, what is number of moles of solute? Number of moles of solute is also grams or mass of solute divided by molar mass of solute. Correct? Multiply density, multiply 1000 into mass of solution. Okay. Now this grams of solute by mass of solution is what? W by W, correct? So can I write molarity equals to percentage W by W, percentage इसलिए क्योंकि we always express in percentage, multiply density, multiply 10 divided by molar mass of solute. Okay, this is the another relationship which is of importance, which we can use in some questions going ahead. Okay. Now, as a homework, I want you guys to find out the relationship between molality, molarity, and density of solution. This is your homework. Please put your answer or your homework in the comment section. Okay, so this is your homework where you have to find out the relationship between molality, molarity, and density of solution. Nothing, try to just use certain terminologies and remove certain terminologies from here and there, and you'll be able to find it. Okay, and it is not a very simple relationship. If it's okay, even if you are getting a weird answer. Okay, so put your answer in the comment section, and further we can discuss about this relationship. Clear? Now, let's do a few questions on the basis of how does these relationships and how the terminologies can be asked in some questions. Okay. Okay, let's do one question, which is, okay. For example, if 5.2 molal aqueous solution of CH3OH is supplied. What is the mole fraction of alcohol in the solution? Very easy. What we are given. So whenever you have to solve this type of question, you have to always written what is given. What is given to us? 5.2 molar aqueous solution means there is a water which is present as a solvent and CH3COH is a solute. CH3OH is solute and water is solvent. Correct? Now, this 5.2 molar means what? That 5.2 moles of solute is present in 1000 gram of solvent. Correct? This is what it means, right? So, and what is mole fraction? Mole fraction will be moles of solute divided by total moles. Means moles of solute plus moles of solvent, right? So what is moles of solute? It is 5.2 divided by total moles. Moles of solute plus moles of solvent. Abhi solvent kya hai? Water. Water ka how much grams we have? 1000 divided by 18. That will give us the moles of solvent. So we calculate it, we'll get the mole fraction of CH3OH present in 5.2 molar solution of aqueous solution. Okay, so this is 5.2. This comes out to be 18. 55.55, I guess. Right? So it will be 5.2 divided by 60.75. Okay, so you can do the maths and you'll get the mole fraction of the given solution. Clear? We can do one more question and then we can wrap up the video, and you can try out different questions and put your doubts in the comment section. Okay, one more question. The density of a 3.6 molar H2SO4, that is 29% H2SO4 by mass will be. Okay, so it means we have to find out the density of the solution, right? And we are given with molarity. What is molarity? 3.6 molar H2SO4 solution. And what is percentage W by W? It is 29%. It means 29 grams of H2SO4 is present in 100 grams of solution. Correct? Here. Now, what is the formula of density? Density is mass of solute or mass of solution divided by volume of solution. Okay. Clear? How you will find out the volume and the mass of solution? Now, density equals to mass of solution. Before that, what is molarity? Molarity means 3.6 moles of H2SO4 is present in 1000 liter of solution. Correct? So the volume of solution we know, which is 1000 liter. Now 3.6 moles. Now 3.6 moles means what? 3.6 moles means grams divided by molar mass. So what are the grams of H2SO4? Grams of H2SO4 is 3.6 into molar mass is 98. So 36 into 98 by 10 will be the grams of H2SO4. Correct? Now we need what? We need the grams of, second. So these are the grams of H2SO4. Now imagine what we have a relationship which says 29%. Matlab 29% of total mass of solution should be equal to these many grams, 36 into 98 by 10, right? So means 29 by 100 of X, which is the mass of the solution, should be equal to 36 into 98 by 10. So X is equal to 36 into 98 into 100 divided by 29 into 10. Okay. So this will give us the mass of solution. We already have the volume of solution, which is 1000 ml, and the mass of solution is given. So density of solution will be grams, which is 36 into 98 into 10 divided by 29. Right? This is the grams, and then the volume is 1000. Right? So what will be our answer? 36 multiply 98 divided by 2900. No? This comes out to be 1.21 gram per ml. Okay? So this is the density of solution. So this is how you are supposed to solve the question. Whenever you get confused, you have to refer the formulas. Okay, and using that formulas, you can find out the relationships and finally reach to your final answer. that's it for today's class. I hope you guys understood everything. If you have any doubts, if you have any doubts in terms of concepts or number of questions or the type of questions, put your answers or put your doubts in the comment section and we can discuss about it. Okay. And do not forget to subscribe our channel. It is really important for us and for you also, so that we can keep making the videos. Please share this with the people who also require it to understand the concepts. Clear? Thank you so much.